Right now, while you're watching this video, hundreds of satellites are orbiting Earth at thousands of kilometers per hour. Some help us navigate, some relay communications, others observe events on the ground. Most people never see them, but they quietly support technologies used around the world. So how do military satellites really work? Today, we're going beyond the clouds to uncover the invisible technology shaping modern defense. Imagine trying to understand what's happening across an entire continent while standing on the ground. Now imagine looking from hundreds of kilometers above Earth. Space provides a unique vantage point, allowing satellites to cover vast areas and support communication, navigation, and observation. But simply being in space isn't enough. What these satellites do next is even more fascinating. A military satellite is a spacecraft designed to support defense-related missions. Different satellites have different roles. Some provide secure communications, some help with navigation and timing, while others collect imagery or detect events from orbit. Think of satellites as cameras in the sky, but they're much more than cameras. Depending on their sensors, they can gather different kinds of information, helping build a broader understanding of what's happening over large areas. But seeing the Earth is only one part of the mission. The next job may surprise you. Imagine trying to make a phone call from one side of the world to the other without undersea cables. Satellites can help relay signals across enormous distances, supporting communications in places where other infrastructure may be limited. Many navigation systems rely on satellites that transmit highly accurate timing signals. Receivers compare those signals to determine location, helping aircraft, ships, and many civilian technologies navigate with precision. But what happens when weather or darkness makes observation more difficult? Not all satellite sensors work the same way. Some are designed to collect information in daylight, while others can operate in different conditions using technologies beyond the visible spectrum. Some satellites are designed to detect intense heat signatures from high above the Earth. These systems can contribute to early warning by identifying unusual events and rapidly relaying information to command centers. But satellites don't work alone, and that's where the Rail story begins. One satellite can provide valuable information, but a network of satellites can achieve far more. By working together with ground stations and other systems, they help create a more complete picture of the situation. Operating in space isn't easy. Satellites must withstand extreme temperatures, radiation, and the harsh environment of orbit while continuing to perform their missions reliably for years. Satellites don't make important decisions on their own. Across the world, ground control stations monitor their health, adjust their position when needed, and manage the flow of information. Think of them as air traffic controllers, but for spacecraft orbiting Earth. But controlling a satellite is only half the job. The real challenge is getting information back to Earth in seconds. When a satellite collects information, it doesn't keep it. Using radio signals, it transmits data to specially equipped ground stations. Those stations process the information and distribute it to authorized users who need it. You might think the biggest danger is the darkness of space, but one of the greatest challenges is orbital debris. Even tiny pieces of debris travel at tremendous speeds and can damage spacecraft. Engineers carefully track these objects to reduce collision risks. And if avoiding debris is difficult, imagine launching a brand new satellite into orbit. Every satellite begins its journey aboard a rocket. After reaching the correct altitude, it separates from the launch vehicle, deploys its solar panels, and begins months or even years of operation around Earth. Without fuel stations in space, satellites rely heavily on solar panels to generate electricity. That energy powers onboard computers, communication systems, and scientific instruments, while rechargeable batteries provide power during periods without direct sunlight. But today's satellites are only the beginning. The next generation could be even smarter. Future satellites are expected to become more capable through advances in computing, communications, sensors, and autonomous operations. Researchers continue exploring technologies that could make space systems more resilient and efficient. Artificial intelligence may help satellites organize information, monitor their own systems, and support operators by identifying patterns in large amounts of data. Human oversight, however, remains essential for important decisions. But one question remains. Could the future of military technology depend on what happens in space? Space supports far more than satellites. It connects navigation, communications, weather forecasting, scientific research, and many other technologies that people use every day. Its importance continues to grow as technology evolves. As engineers continue developing new spacecraft and more advanced technologies, satellites are expected to remain a vital part of the world's technological infrastructure. The innovations of tomorrow may begin hundreds of kilometers above our heads. Every time you use navigation, communicate across long distances, or look at an image of Earth from space, you're seeing the impact of satellite technology. From communications and navigation to observation and scientific discovery, satellites quietly shape our modern world. The next time you look up at the night sky, remember, there's far more happening above us than meets the eye. If you enjoyed this documentary, subscribe to WarTech and join us every Tuesday and Friday as we explore the technologies shaping the future.